All right, friends, welcome back for part 2 of 1-6, Compound Inequalities Notes. So, yesterday we talked about solving inequalities with OR statements, and today we're going to talk about AND statements. We also talked about what and OR compound inequalities look like and how to solve OR compound inequalities. So an AND inequality looks something like this, or it looks like B, where it gives you two separate inequalities and separates them with AND. They can disguise themselves either way. The first thing that we do in order to solve these inequalities is write them in two different ways. So I'll write this as negative 12 is less than or equal to 7x plus 9. That's our first one. And our second inequality is 7x plus 9 is less than 16. So all I'm doing is I'm taking this guy and writing it here and here. And then I am taking the other parts of the inequality and writing it there and there. All right? Okay, now that we have our two inequalities, we solve them exactly how we did yesterday. So first things first, I'm going to subtract 9 on either side because we do the opposite of addition or subtraction first. And I get negative 21 is less than or equal to 7x. Now I'm going to divide both sides by 7. And I get negative 3 is less than or equal to x. Then I'm going to graph that so I don't lose track. I'm going to have a closed dot at negative 3. So I'm going to erase that, put that at negative 3. And then I know that x is bigger than that. So my arrow would go this way. Another way that you can write this answer would be x is greater than or equal to negative 3. These mean the exact same thing, so it does not matter, but that is why it goes to the right, because the alligator always eats the bigger sign. Now let's go to the next part of the AND statement. I'm going to do this in blue. I'm going to do the same steps. I'm going to subtract 9, and I'm going to have 7x is less than 7. And now I'm going to divide both sides by 7, and I get x is less than 1. This is an open circle at 1. And I also know that x is less than all the numbers than 1. So I'm going to go this way, because those are all the numbers less than 1. Now I need to combine those graphs together. So I'm going to have a closed circle at negative 3, and then an open circle at 1. And then their arrows should overlap, and you only need them to overlap that far, and that's it. And that's all it is. This is your answer right here. Here and here. You can also write your answer as x is negative 3 is less than or equal to x, which is also less than 1. This can also be an answer that you write as well. But this is your graph. Okay? All right, part B. I'm going to give you the answers just like I did yesterday, and then you have to graph them and figure out the combined graph. Okay? So pause. I'll see you in a sec. Okay, I'm back. So I got x is greater than negative 3 for the first one, and x is less than or equal to negative 1. And now what you need to do is graph those and then combine them onto one number line and see what you can get. Number, or letter C, is your you do. So you need to have that one all tried out. Remember, the more you do, the faster it goes. And then you need to do a question or connection for this page. All right? And also take a crack at that chunk summary number 3. And then when you are all ready, I will meet you on the back. All right, on to our last example for this page of notes, example 4, solving problems using compound inequalities. Enrique, he's planning on using a diet for his dog, River. And River consumes between 510 and 540 calories per day. If River eats 1.5 servings of dog food each day, how many treats can she have? So we want to know how many treats that she can have. So our first step is going to be defining a variable. So X is going to represent the number of treats that this doggo gets to get. Okay. Then we need to create an expression for River's daily calories. So we know that the calories per serving in her dog food is 320, and the calories per treat is 15. So my expression for her, how many calories that she gets to have each day, is she's having 1.5 servings, so 1.5, which is the same as 1.5, times 320, because that's 1.5 servings of dog food, and the dog food is 320 calories. Okay. In addition to all of her dog treats that she gets, which are 15 calories, and we don't know how many treats, so she's going to have an X, and that's our expression. Now I need to multiply 1.5 times 320, and when I multiply that, I get 480, and then I'll just add the rest of the stuff down. So this is our expression. Okay, now it's in between 510 and 540. So the minimum that we want River to have is 510 calories. And she can have 510 calories equal, and everything would be fine. But she also wants more than that. And then we'll put our expression right here, 480 plus 15x. And then our maximum that we want her to have is 540 calories. So in between, think about it as an and inequality statement. All right, now this breaks up into two separate inequalities. We get 510 is less than or equal to 480 plus 15x. And then the next one, I'll do it in red, is 480 plus 15x is less than or equal to 540. Okay, so now we're going to solve each one of these separately. I'm going to zoom in. So at first, I'm going to subtract the 480 from either side. And when I subtract 480 from either side, I get 30. And 30 is less than or equal to 15x. And then I'm going to divide by 15, because divide by 15, and I get 2 is less than or equal to x. So she can have at least 2 treats first. Now let's see what's the maximum amount of treats that she can have. We're going to do the same thing. Subtract 480, and I get 60. So I get 15x is less than or equal to 60, and I'm going to divide by 15. And I'm going to have x is less than or equal to 4. So our solution is x has to be in between 2 and 4. And if we want to say this in words, River, who's the dog, can have at least 2, but no more than 4 treats. And that's our answer, both of these. All right, let's help for number 2. This one's going to be your try it, but I'm going to help you set it up. Suppose River has new treats that are 10 calories each. How many of the new treats can she have and still remain in her calorie range? So our expression's not really going to change, except for the 15 is going to change into a 10. So we're going to let x still equal treats. And our expression she's still eating 1.5 servings of dog food, and the dog food is still 320 calories per serving. And instead of it being 15 calories per treat, it's going to be 10x. And then her calorie minimum and calorie maximum didn't change. So our setup is still going to be 510 is less than or equal to 480 plus 10x, because this is equal to 480, is less than or equal to our maximum, which is 540. And then you're going to break it up and solve for x. All right, and just like that, our videos are complete. Reminder, question or connection. And I will see you tomorrow. Bye.